Organic Chemistry O-Levels IGCSE Alkanes, and we're going to be solving a bunch of MCQs, and we're going to spot the difficult questions, and I'm going to explain the difficult concepts to you guys. So let's get started with this paper. We're going to start with MCQ number 6, which says the diagram shows two compounds, ठीक है? It can be predicted from their formulae that the compounds have the same, and we're given with three options. So let's figure out what is common in these two compounds. So the first step we're going to do is we're going to count the number of carbon atoms in both of the compounds. So ठीक है? First let's count in the first one. That's 1, 2, 3, 4. So we have 4 carbon atoms. So I'm gonna write C4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. So well, in together we have C4H10. ठीक है? Now let's move on to the second compound. It has 1, 2, 3, 4 carbon atoms, which makes it C4, and 1, 2, 3, 4, 5, this one's 5, 6, 7, 8, this one's 8, 9, and 10. And 10 hydrogen atoms, which makes it C4H10. ठीक है? Whenever you count the number of carbon and hydrogen atoms and then you write it like this, in this form, when you count them and write it like this basically is known as the molecular formula. ठीक है? This is known as the molecular formula. Remember this thing, whenever you count the number of carbon and hydrogen atoms and write it in this way, that's known as the molecular formula. So the molecular formula of, let me call this as my compound 1 and this as my compound 2. So the molecular formula of compound 1 and compound 2 are exactly the same. That's C4H10. So it can be predicted from their formulae that the both compounds have the same boiling point. No, we are not sure about that. We cannot predict it by our own self. Composition by mass. Well, that's a good term, and let me explain what this means to you. Wait a sec. First, I'll, look at option C and D. Melting point, no. Structural formula, not at all. The structures of both these are completely different. How can the structures be different is, look, in the first one, we have C4H10, but the structure is different because all the carbon atoms are in a straight chain. What do I mean by the term straight chain? For example, if I start joining all the carbon atoms together, I can join them in one go. Like, for example, I start with this one here. I can join it in one go like this. I can easily join it at one go by, I don't have to pick up my pencil to join them. Okay? That's like a straight go, a one-shot join. Whereas if I look at the second isomer, which I'll call it an isomer because I cannot join this, this thing in a straight go. Let me try to join it. First, I move from this carbon to this, and now I'm confused. Either I can go down or I can go up. But the problem is, for instance, I choose to go down like this. Now the problem is this carbon atoms is left behind. I cannot join this and these two at the same time. I have an option. Either I can go like this one. If I join this carbon atom is left. So both of them have different structures. These both are structural isomers of each other. These both are structural isomers. Why are they structural isomers? Because I cannot join them in one go, and they have different structures. This is a straight chain butane and this is a branched butane. Okay, there's a branching on this second carbon. I hope you guys got this thing. Okay, these both have the same molecular formula. Okay, it is also C4H10. This one's also C4H10. But the problem is, okay, this one is straight chain. This one is branched. Okay, that's why they have different structure. The different structural formula. ठीक है. Now let's look at option B, which says composition by mass, which we left. Now there's an interesting thing over here. Composition by mass means that each element in the compound is in the same ratio or is in the same percentage. ठीक है. Now what we do is कि मैं कहती हूँ, I say that 40%, 4 means 40%, ठीक है. I say that 4 means 40%, ठीक है. C4 मतलब जो कार्बन है इसमें वो 4 का मतलब है 40, तो 4 40 है. और अगर मैं कहती हूँ तो अगर 4 40 है तो 10 100 है. तो हमारा वैसे ये बहुत लेम एस एग्जाम्पल है, इट्स अ वेरी लेम एस एग्जाम्पल बट स्टिल जस्ट टू मेक इट क्लियर. और मेरा जो हाइड्रोजन है आई से कि वो 10 100 को रिप्रेजेंट करे, तो दैट मीन्स दैट आई हैव 40 कार्बन एंड 100 हाइड्रोजन्स. ठीक है. अब हम इस पे आते हैं, दिस वन. ठीक है. द गुड थिंग ओवर हेयर इज इट ऑल्सो हैज़ 4 कार्बन्स एंड 10 हाइड्रोजन्स, विच मीन्स मैं 4 कही थी, मेरा 40 है और 100. इस पे भी मेरा वही आंसर आ रहा है. देखें, this means that these both have the same composition by mass. The composition of carbon is the same in both. Both have 4 carbon atoms and both have 10 hydrogens. So the composition by mass of these both isomers are same, exactly the same. Let me write one point. That is a very important point. This thing what I am writing over here is very important. If two compounds have the same molecular formula, they have the same molecular formula, then they have the same composition by mass. This concept is very important. Why? Because if they have the same molecular formula, then what will happen? This means that the number of substance in both is the same. अगर इस वाले में हमारे पास 4 कार्बन्स हैं तो इस वाले में भी हमारे पास 4 कार्बन्स हैं. अगर इसमें हमारे पास 10 कार्बन्स हैं, इसमें भी 10 हाइड्रोजन्स हैं, तो इसमें भी 10 ही हाइड्रोजन्स हैं. The number is the same. Composition by mass same है. अगर मैं 14 पार्ट्स इसके लेती हूँ तो मुझे पता है कि 14 में से इसमें भी 4 जो है वो हाइड्रोजन है और जो 10 है वो 4 जो है वो कार्बन्स हैं और जो 10 है हाइड्रोजन है. अगर मैं इसके 14 पास देती हूँ तो उसमें भी मुझे पता है 4 में कार्बन है और 10 मेरे हाइड्रोजन है. तो दोनों में अमाउंट प्रोडक्ट कह रही हूँ, दोनों में अमाउंट कार्बन और हाइड्रोजन्स की सेम है. ठीक है. सो दे हैव द सेम composition by mass, which makes option B the correct option. Now let's move on to question 7, which says, which statement concerning isomers is true? Which statement concerning, the key word in this question is isomers, is true? Diamond and graphite are isomers of each other. Not at all. Diamond and graphite are not isomers at all. Why they aren't isomers? Because look, diamond and graphite are allotropes. Allotropes क्या होते हैं? They have the same element but they have different physical forms of each other. देखें, कार्बन का आइसोमर कैसे हो सकता है? देखें, डायमंड जो है वो किस चीज़ से बना हुआ है? डायमंड इज कार्बन, या डायमंड इज कार्बन, है ना? Does diamond contain any other element apart from carbon? No. Diamond only and only contains carbon. There is nothing in diamond apart from carbon. And graphite. What's graphite? Graphite is also carbon. ठीक है? Graphite is made up of carbon. Diamond is made up of carbon. There is no other element in both of them apart from carbon. How on earth can they be isomers of each other? क्या carbon का isomer हो सकता है? Can carbon be an isomer of carbon? Diamond is pure carbon. Graphite is pure carbon. They cannot be isomers of each other at all. कार्बन का आइसोमर थोड़ी ना हो सकता है. आइसोमर तो होता है कि स्ट्रक्चरल फार्मूला डिफरेंट बट मॉलिक्यूलर फार्मूला सेम. अब इन दोनों में डिफरेंट स्ट्रक्चर्स हैं दोनों के, बट प्रॉब्लम है ये बात नहीं है कि इनका मॉलिक्यूलर फार्मूला सेम है. दे बोथ आर isomers. They cannot not be isomers. They both are the same thing. They're both the same element. An element in isomers are in compounds, not in elements. Okay, now let's view option B, which says isomers have the general formula CnH2n plus 2. How on earth can this be the general formula of isomers? This is the general formula of which group? Which group of hydrocarbons is this the general formula? Alkanes. Okay, this is the general formula of alkanes. Okay, it is not the general formula of isomers. Isomers don't have any specific general formula. Isomer is simply like you have two compounds, they have the same molecular formula, they have this different structural formula. ये देखें, ये ऊपर जो था, look, same molecular formula C4H10 C4H10, ये दोनों का same है, but different structures दोनों के हैं. तो these two are isomers of each other. ठीक है? I hope what I'm saying makes sense to you guys. Now let's view option C, which says isomers have the same molecular formula. That is what I was saying, कि isomers always have the same molecular formula and different structural formula. So the answer is going to be option C. Let's view option D as well. Macromolecules are isomers of the small molecules from which they're made. Not at all. Macromolecules are not isomers at all. Macromolecules are polymers, and the small molecules from which they are made are monomers. So they're just trying to confuse the concept of polymerization with isomerism, and that's completely senseless because macromolecules are polymers and the small units that make up those macromolecules are the monomers. How can they on earth have the same molecular formula? That's completely not true. Now let's move on to the next question. Question 8, which says compound X and Y are both alkanes. Compound X has a higher boiling point than compound Y. ठीक है, जो X है, it has a higher boiling point than compound Y. What could be the formulae of compounds X and Y? Now, this MCQ basically, reinforces the concept of that the more the number of carbons, okay, let me draw this thing for you. You're going down like this. Okay. Over here you have 1 carbon. You have 2 carbons. You have 3 carbons. You have 4 carbons, and you have 5 carbons. Now mark my words, what I'm saying. As the number of carbons increase, the melting and boiling points increase. What I said, mark these words, that's super important concept that's going to be every time tested. As the number of carbon atoms increase, the melting and boiling points to increase. I hope what I've written makes sense to you guys. Look, first one we have methane. For instance, I consider this methane C1. Carbon 1 होता है ना methane में. Methane, ethane, propane, butane, pentane. ठीक है? Methane is going to have a lower melting and boiling point than pentane. Why? Why is methane going to have? Because methane has 1 carbon. ठीक है? Methane has 1 carbon, whereas pentane has 5 carbons. Pentane has 5 carbons. The more the number of carbons in a compound, the higher the melting and boiling point. अब मैं एक नया compound I'm introducing C10, which is decane. Decane is going to have the highest melting and boiling point in this chain because it has more number of carbon atoms. What I told you, if you take decane, it's going to have a higher melting and boiling point than all of them. That's because it has the highest number of carbon atoms. ठीक है? The more carbon atoms you have, the higher the melting and boiling point you have. So what they're telling over here is that compound X and Y are both alkanes, and X has a higher boiling point than compound Y. X meaning that X has higher point and Y has lower. What that means is that X is going to have more carbon atoms than Y. X is going to have more carbon atoms than Y. ठीक है. Now, in these two options, X should have more carbon than Y. This cannot be X because it's 8 and this one's 9. ठीक है. This is 8, this is 9. No, not possible. This is 9 and this is 8. Well, you might think that C is the correct option. You might think that this one's 9 and this one's 8. However, there's one important line that you guys forgot. Compounds X and Y are both alkanes, whereas this compound and this compound are both alkenes. C9H18. That cannot be an alkane because alkanes have the general formula CnH2n plus 2. So you got to add 2 to it. So D is the correct option. Because why is D the correct option? Because look, this one's an alkane, this one's an alkane. And X, as X has a higher melting point and boiling point, that means X has more carbon atoms. C in X, C is 9 and at Y, C is 8. 9 means more carbon, so higher melting and boiling point. M and B points. I hope this point made sense to you and you understood all of this. Thanks for watching my video. Do consider subscribing, and that's all for today.